So 2 minus e to the minus 0 becomes, since any e to the power of negative 0 is just e to the power of 0, anything to the power of 0 is 1, so I end up with 2 minus 1 here. And then the y value when x is 0 is 1. So my intercept would be 0, 1. Right? Now, the second part of this question was show that f of x is increasing for all of x. All right? And in order to do that, to show that an interval is increasing, we have to show that find f prime of x. Okay, so we're going to use f prime of x to show that f of x is increasing. Well, what is f of x? Well, what was f prime of x? Well, f of x was, let's just rewrite that here, 2e to the minus x, right? Sorry, 2 minus e. It should be 2 minus e there. Whoops. Okay, so f of x equals 2 minus e to the minus x. If I take the derivative of that, then I end up with that goes to 0, and now I have minus e to the minus x times minus 1, so that becomes e to the minus x. All right. So what are the zeros of this? Let's use a sign diagram here. What are the zeros of f? Oh, wow, that was kind of weird. Okay, sorry about that. What is the sign diagram of this going to look like? Well, here's f prime of x. Are there any zeros? Are there any values of x that will make this go to 0? No, there are no zeros, okay? So there are no zeros, and therefore there's only one interval to test. So all I need to do is test this one interval, and I can pick any number. Let's pick 0 because that's a nice one. 0, if I put f prime of 0, or if I put f prime of 0 in, then I end up with a positive number because the base is positive, right? So this is going to be positive. So it's positive on the entire interval. So this is for all x, and therefore we can say since it's increasing, since f prime of x is increasing for all x, or sorry, is positive, then f of x is increasing. Okay? Increasing for all x. All right? Let's try the second part. What was the second half? It says show that f of x is concave down. So you can see where this is going. If I need to show it's concave down, I'm going to use my second derivative. Okay? And with my second derivative, I'm going to create a sign diagram, and hopefully, since it's concave, to show it's concave down, okay, to show that it's concave down, this entire interval should be negative, right? So let's find f double prime of x. Okay, so here's f of x. So if I derive that, I get e to the minus x times minus 1 using the chain rule, and with minus e to the minus x. Okay, what are the zeros of this? Well, there are no zeros again. Okay, the only difference between this and this is that now this is flipped, so it's negative. And since f double prime of 0, sorry, that should be an x, by the way. F double prime of x is going to be less than 0 for all x, right? Because any number that I put in here, this part will become positive, and then I have the negative multiplied to it, so the whole interval, on the whole interval, the double prime f of x is going to be negative. Okay, so since it's negative, we can say it's concave down, and so since let's write that over here. Since f double prime of x, is less than 0 for all x, f of x, my original function, is concave down. Okay, for all x. All right, so that would be how you do that one. Okay. Let's take a look at example 3 here. Given the graph of f of x, sketch f prime of x and f double prime of x. Okay, well obviously here I haven't shown you the graph of f of x, so let's go ahead and graph that. All right, let's graph this and let's make it look like that. Okay, so this looks pretty similar to what we did in our previous one, but let's just try it here. Okay, so here's the graph of f of x. Okay, here's y equals f of x, and I'm asked to sketch f prime of x and f double prime of x. Okay, so right away you can see here that I have some interesting points. Okay, I have a critical point here. At this point, I'm going to have f prime of x is going to be, f prime of x will be 0. Okay, and at this point, it looks like I have a non-stationary point of inflection. Since I have concave up, concave down, that would be a point of inflection. And since it's not a maximum or a minimum, we can say, well, that's got to be also, the derivative would be equal to 0. Okay? So we're making some deductions here after looking at this, looking at the shape. And also at this point, okay, since we have concave up and concave down, and then concave back up, this point looks like it's going to be a point of inflection. Okay, and since it's not, since f prime of x I know is not 0, right, because it's not a maximum, it's not a minimum, and it's also not a stationary point of inflection, it's got to be f prime of x is some number. Okay, so f prime of x is not 0, but we do know by looking at the curvature that f double prime of x is going to be 0. Okay, since we have a change in concavity, we can assume that there's a point of inflection here. Okay, so let's go ahead and graph this. If I want to graph the derivative of this, okay, well that point right there is going to be a 0 of f prime. That point right there is also going to be a 0. Okay, so let's try and make this as straight as possible. We would, and we're going to assume the same x and y axis. Okay, I'm just doing it on a different graph. All right, so whatever this x value is, that x value will stay the same, and on the graph of f prime of x. So there's a 0, there's a 0. All right. Now what's the sign diagram of f prime of x going to look like? Well, here, remember the sign diagram we can determine by looking at the shape of the original function, or the intervals of increase and decrease of the original function, sorry. So here I have negative, so here I'm decreasing and increasing, 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 right? So that means this interval from here to here is going to be negative, okay, on my f prime of x. It's going to be decreasing down here. It's increasing from here to here, so that's going to be increasing. From here to here, it's also increasing. So we now have a graph that will be decreasing here, or sorry, negative down here. So all my y values will be down here, all my y values will be up here, and all my y values will be up here. Okay, well, that I don't think I have enough information right now to graph this. Okay, but I know that the basic shape is going to look something like, if I were to do a quick sketch, it would probably look something like all my values would be down here. Okay, it looks like this side's going to be increasing negatively, right? Because it's this side would probably go curve up and it would get more steep as my x becomes more negative. And I would have a value here, a value here. It's positive here and positive here. So it looks like all of my values will stay up here. It's got to come back down here, and it's got to be up here. So it looks like this side's going to look something like this. Okay, so probably over here as I go into infinity, it looks like my slope is getting more and more steep. So my x is going to get larger here. So what do you anticipate is going to happen over here? Well, most likely, since all of my values have to be positive up here, and it's going to come back and touch these two, it's probably going to end up looking like that. Okay, and that makes sense, right? Because this is a cubic. That looks like a cubic, and this looks like a quartic. Okay. Now I'm just assuming here. Okay, this might not necessarily be the case in all diagrams like this. So you might get more complicated answers where you'd still have to use your knowledge of first and second derivatives to do these curve sketches. But in this case, that's what it looks like is going to happen. And let's verify that by doing the second derivative graph. Okay. All right. The second derivative graph, well, we can figure out now. Let's see. We said that the points of inflection here, I have two of them. I know these are 2 points of inflection. This is going to be a horizontal point of inflection. This is a non-horizontal, right? So I have these 2 points of inflection. These 2 points will be the points that when f double prime of x is equal to 0. Okay? So I can deduce this because it's a point of inflection, because I know there's a change in the curvature. So I'm going to look at the curvature mostly to determine the shape of my f double prime of x graph. Right? So since right here I would have a point of inflection, that means the y value would be 0 on my f double prime of x graph, and that point right there corresponds with that point. Okay, and let's take now we can let's look at the sign diagram. So those are my critical points basically. All right, on my second derivative graph. Okay, and what would be my sign diagram in this? So I have 3 intervals. What would be my sign diagram right here? Right here, well, this curvature is going up. It's pointing up like this, right? So that would be a positive. Okay, so my values would be up here somewhere. That would be a positive. That would be a positive. Okay, most likely, let's just draw a quick sketch before I do this. I would probably end up with positive values up here. It's got to be above the x-axis. In this interval between this point and this point, my curvature is down. So my curve, here it's positive, here it's negative. So my sign diagram for my f double prime of x would be negative in this interval. And in this interval, it's back to curvature up, right? Back to curving up. It's concave up. And so we would have a positive over here. So it looks like we're going to have positive values over here, positive values over here, and down here we're going to have negative values. Okay, so that's really what's happening. I'm going to have a parabolic shape right here. Okay, now what about f prime of x? Okay, let's look back at f prime of x. At this point, this is my inflection point. We said it's going to look something like this. Okay, it's probably going to look like this. At this point, at this inflection point, we know that the f prime of x is not 0. And in fact, we can assume we know that this will be a critical point. Okay, whenever the second derivative is 0, the first derivative will have a critical point at that x value, and that makes sense, right? If I have f of x and I take the derivative of it, well, the zeros of this will be the critical points of this, right? The stationary points. So at I guess I could say when the double f prime of x, when f double prime of x is equal to 0, f prime of x has a critical point or a stationary point. Okay, which means it could be a local max, min, or point of inflection. Stationary point of inflection. Now this I'm referring to f prime of x, not f of x. Okay, so it can get a little bit confusing here, but just keep that in mind since I'm looking at the derivative of the first derivative. Okay, so it's just the same thing as when I was talking about f and f prime. Okay, so that means this would be a critical point. And it looks like since it looks like since my shape has got to be here, okay, it's got to be continuous here, that it's going to be a maximum. Okay, so we know it's going to be a maximum at that point. So this would be the graph of f prime of x, and this would be the graph of f double prime of x. All right.